So for this lesson, we're going to go over more postulates and theorems. Let's see, there's 5 that we're going to go over today. And these are just more proven reasons of why certain angles or certain measurements can be considered corresponding or congruent to another one. So the first one we're going to look at, let me take a picture. Is postulate 16. You will probably use this one more than any of your other postulates, especially at the beginning. Postulate 16 says, is the corresponding angles are converse. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So remember how we had the postulate a couple lessons ago where if you had 2 parallel lines cut by a transversal, it told you that these 2 measurements were corresponding. Okay, all postulate 16 is the reverse of that. It's saying if you have 2 corresponding angles on 2 lines cut by a transversal, then you know for sure that these 2 lines are parallel. So it's just stating what that old postulate had, but proving it backwards. It's the only difference, okay? Let's look at example 1 and use postulate 16 to solve it. All right, so we have, put this in your journals. We have this diagram and it says find the value of x that makes m parallel to m. So they want us to assume that these 2 are what? Equal. They're congruent, right? Because we're assuming that the two lines are parallel lines. In order for those to be parallel, this angle has to equal that angle. So to solve for x, what would I do? Yep, just set them equal to each other. So 3x plus 5 equals 65. Now let's solve for x. So first step, I subtract 5. Then I divide by 3. So x equals what? 20. And I wanted you to solve for x. So, yay, done. All right, let's look at our other theorems that we need to go over. Now you have all of these in your journals, right? Okay, so Theorem 3.4, alternate interior angles, converse. Again, we've had these proving if we had 2 lines that are parallel, these angles are alternate interior equal each other, right? Well, now we're just going backwards. So now I'm saying if I have 2 alternate interior angles are congruent, then those lines got to be parallel. Same thing with the Theorem 3.5, alternate exterior angles. If they're congruent, then the lines are parallel. And consecutive interior angles. If they're on the inside, same side of the transversal, and they add up. Do you guys remember what they have to add up to? 180. They're supplementary. Then if that happens, then the 2 lines are parallel. So that's all you're doing with your theorems is the reverse of the ones you did from, I think it was 2 lessons ago. All right, so let's look at example 2. How can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake. Let me take a picture here. All right, here's a microscopic view of the pattern on a diamondback snake. You can see that we have two lines cut by a transversal, right? Yeah. Because here's your two lines, and then your transversal cuts across it. You see that they have said that this angle equals this angle. Well, what are those? Alternate interior angles. So because of theorem
3.4.
Very good. 3.4, we can say that those two lines are parallel. So you would say theorem 3.4 proves lines are parallel. A lot of this lesson is just telling me why a certain statement is or is not true. Okay. The last thing I want to go over is Theorem 3.7. So turn to page 156. All right, you've heard this word transitive before. Transitive property of parallel lines. If two lines are parallel to the same line, then they are all parallel to each other. Okay, so this is just one of those theorems you can use when you're solving for measurements. So if they tell you the measurement of line P, then you know the measurement of line Q and R because they're parallel lines. Okay, that's it, guys. It's pretty simple. What I want you to do is numbers 3 through 15 and 27 and 28. Let me see if I want you to do 27 and 28. 27. Yeah, 27, 28. And all you're literally doing is telling me, solving for x on a bunch of these, finding the value of x for numbers 3 through 8. For numbers 10 through 15, you're just telling me, can I prove that those lines are parallel? And if it is a yes, then you would tell me which theorem or postulate you used to prove it. You know, like for number 10, alternate interior converse theorem. Or you can put theorem 3.4. Okay? That's literally all you're doing. There might be one or two in there that you can't prove. You'll just have to say no. Okay? 27 and 28, you're also just solving using that diagram. Okay, that's it. Pretty easy lesson.